So, thank you very much for inviting me to this very inspiring conference. I apologize that I can only speak in English. What I would like to show you is some recent research results from Austria. The question that was posed is, and it was coming from policymakers in fact, what is the best to do if we want to save our contribution on national level to the climate change problem? What is the best solution in construction? What can we do best to support the climate? And this question was posed on two levels. It was once posed on the overall climate balance of the country of Austria, the balance of the forestry and the use of materials, and it was a second time posed on the level of buildings. And I want to show you now some of the results of these research projects carried out. This is how the timber industry in Austria, which is very active. Of course, Austria is a timber country, a forest country like Slovenia. So our timber industry is very active. This is what they say in their advertisements. Yeah? 1 cubic meter of timber saves 1 ton of CO2, and if you use as much wood as possible, then you actively contribute to climate protection. I do not deny that this causes us troubles. Yeah? In the brick industry, we are convinced that houses should better be built with our products. And I've heard already some discussions here in the first panel on this question. But besides, it's also a good question for policymakers, what is true? Yeah? So the question is this really true? And in fact, our government ordered some very interesting research projects. You see here which organizations were involved. And you will see these organizations are relatively close, I would say, to the timber and to the forest industry. So that was their own institutes that did the research, like for example the Federal Research Center for Forestry. And all these 3 projects were publicly funded, so the government stands behind these results. And they looked, we are now on the level of the country, the global level if you want, so in Austria, and they looked on the climate balance of Austria, the CO2 balance of Austria in the period between 2010 and 2100 along 5 different scenarios of forest management and use of timber in our country. The scenario R, the reference scenario, is business as usual, so continue with the use of timber products as we do at the moment. Then, in principle, scenario 1, with 3 different sub-variants, is an increased use of timber, so take more out of the forests and use more timber, both for product use, for products like houses, etc., and also intensified use for energy. Incinerate this timber and produce electricity out of it. Increase the use. And the other scenario was reduce the extraction, the use of timber. It's called the nature protection scenario. So let forests grow, increase the area of forests in the country, take less out. Of course, the presumption when these projects were started was that these scenarios, increase the use of timber, should bring the best result. There are some basic assumptions underlying these calculations. And of course, the first principle that's clear, when a tree grows, it binds CO2 from the atmosphere. So there is CO2 embedded in the timber. And then there are two scenarios for the usage, once as a material for products and once for the energetic usage of timber. These are the so-called substitution models. If you use timber for producing a product, you substitute the use of other products, like plastics, let's say. And if you use it for energetic purpose, then you substitute the use of other fossil fuels. So you reduce CO2 emissions from other sources. And then last but not least, there is the storage effect, because the CO2, as long as the product is used, is stored in the timber, and the re-emission of the CO2 is delayed. This is called the harvested wood products. Yeah, and these are the results, which are quite astonishing. You see here green bars, this is the forest. So you see in the scenarios where the consumption is increased, there is a negative impact because the forest decreases. On the other hand, you have positive effects because you substitute energy, fossil energy, you substitute other products, and the brown bar is the sum of all these effects. And the longer this brown bar, the better for the climate. And the astonishing thing now is the only scenario that really adds value, that really brings a benefit for the climate, is the scenario where we take less out of our forests and let them grow, increase the area of forestry. Yeah, that was quite an astonishing result, and if you look over the 100 years, then you see there is a certain time development, and this scenario 2 is the green curve. That means over the whole period of these 100 years, this is by far the best that can be done. Let me come now to the second level, the building level. So here the question was, if we look at different variants of construction, heavy materials like brick, like concrete, like aerated concrete versus timber, what leads to the best results? And what I show you here, because in this study they also looked at the cost effects, what I show you here is the costs for different energy levels of the building. These are the three groups of bars, are three different energy levels. And here is compared once a massive construction with an external insulation compared with a lightweight timber frame construction. What you can see here, when it comes to the external walls, the lightweight timber frame construction is nearly double as expensive as the heavy construction. And then there was another big, huge project where nearly all relevant construction materials research institutes in Austria were involved. Our own brick institute, the concrete and cement industry, the timber industry, the plastic industry, so all relevant institutions were involved, and they analyzed 45 variations of houses. So they analyzed total houses built with different materials in different energy levels and with different heating, ventilation and air conditioning systems. And the question was, which of these variations brings the best result? One's on ecological level and one's on economic level. And this is the result, and again it's quite astonishing. I have to explain a little. Here you have 4 different energy efficiency levels. So this is a low energy house, a sun house with a high share of solar energy. This is a passive house, and this is a plus energy house. Of course, this plus energy house has by far the lowest environmental impacts. By the way, what we look here is the so-called GWP, the global warming potential, over a lifespan of 100 years. And what you see here, of course, yes, there is some differences, But if you look at one energy level, there is not so much difference between the different construction types. Blue are different massive construction types, brick, concrete, etc. Brown is timber. So within one specific energy level, the difference between the materials is nearly negligible. And the same result you can find when you look at the comparison of the net present value, so the economic comparison over a period of 50 years, the overall costs are more or less the same. So the conclusions from that is an intensified extraction of timber from forests to use it for buildings is counterproductive for the climate. It is much better for the climate to reduce the extraction of timber and let forests grow. The whole life cycle is approach, that's clear. And if this is done, if you assess a building over the whole life cycle, then the assessment leads to quite similar results for all construction materials. No significant advantage for either of the materials. What is really significant is the energy efficiency of the building. Therefore, all systems that provide subsidies for high energy efficiency, those are put right. On the other hand, the clear recommendation is there is no need for governments to enforce any specific building material. Any specific subsidies for wood, for example, are not justifiable, not based on scientific finding. The decision which material to use can be left to the customer, to the consumer, with good conscience. Rather than subsidizing materials, governments should better subsidize high energy efficiency of buildings, like all these concepts of low energy, passive, solar or plus energy house. This really contributes ecologically and adds value for our climate. So this is the message. I hope that policymakers will appreciate these results. I'm not so sure, honestly, but this is science and this is findings coming from neutral or even close to the timber industry acting research institutions. I thank you. Yeah, last chart I forgot. This is not only findings in Austria. There is similar research going on in other regions as well, and I just have put here some results from a project carried out in US, in Oregon, which come exactly to the same result. Thank you very much for your attention.